Okay, so we talked in our last class, or maybe the class before, but I guess it was our last class, about the directional derivatives and the gradient vector. It might have been the class 2 classes ago. We understand, of course, that if we have a point on a surface, we can find the slope in any direction on the surface uh, using the idea of a directional derivative. And sometimes with these directional derivative problems, you can have a problem like this. And I'm talking about this problem because, hey, you might see it something like this even on your exam, right? Exam number 3. So in this problem here, let's see here. Okay, so in this problem, you're given that the temperature in a metal ball, temperature T in a metal ball, is inversely proportional to the distance from the center of the ball, which we'll take to be the origin. So this makes sense. This makes sense. Basically, as you move further away from the origin, well, if you think about this ball, this solid ball, and there's a temperature to the ball, and you move away from the origin. So think like the Earth, the center of the Earth. The center of the Earth is hottest in the center, right? And as you move away from the center of the Earth, the temperature cools. So here, it's a similar situation. As you move further away from the center of the ball, the temperature of the ball is going to decrease. And how does it decrease? It decreases in a manner such that the temperature is inversely proportional to the distance from the center of the ball. So in this kind of problem, you have to come up with the temperature function. Well, the temperature function is equal to K times 1 over the square root of x squared plus y squared plus z squared. You see, if we were to say, and of course, square root of x squared plus y squared plus z squared just is the distance between some point from the origin. If you have the origin and then you take another point away from the origin, the distance would be the square root of x squared plus y squared plus z squared by virtue of the distance formula. And a lot of times what you're used to saying is, like if you say that A is proportional to B, if A is proportional to B, that means A equals K times B, where K is a constant of proportionality you have to determine. But in this case, we're saying that A is inversely proportional to B, so that equals K times 1 over B. And hence, that's how you come up with this temperature function. So what I'm talking about here is, you could see a problem on the exam where they say temperature is inversely proportional to temperature in a metal ball is inversely proportional to the distance from the center of the ball, which we take to be the origin. And so you got to come up with the function. Well, this is the function. This is the function here. And of course, in order to make the function useful, we have to solve for K. So additionally in the problem, you'll have to be given a value of the temperature. So if the temperature, when x is 1, y is 2, and z is 2 is 120 degrees, you can solve for K. You can then solve for K. Okay? One moment. Let me just... So what you would do is you would say, okay, well, temperature at 1, 2, 2 is 120, and that equals K times 1 over the square root of 1 squared plus 2 squared plus 2 squared. Okay, let me write that maybe a little neater here. I'll do it again. Let me put it in. So the temperature, hold on. The temperature at 122 equals 120, and that equals K times 1, trying to, I think 1 divided by, this is fine, the square root of 1 squared plus 2 squared plus 2 squared. So what you have now is that 120 is equal to K divided by the square root of 9. And so this means that K is equal to 120 times the square root of 9. Okay, that's what that means. Are there any questions on that? Hold on. Let's hit a button. It went ahead. Hold on, Yeva, one moment. Yes, and then I'll mention then what you would do is the 100, let me just see here. Yeah. What you would do is then for this K here, you'd put in the 120 times the square root of 9, and now you have a completely determined function, and you can find the gradient and find directional derivatives and all that. Yes, you have a question?
Is there a reason why we didn't simplify square root of 9 to 3?
Hold on here, I'm having a little trouble hearing you.
Is there a reason we didn't simplify square root of 9 to 3? Or
oh man, that equals 3, doesn't it? Oh my gosh. Yeah, good thinking. So somebody has to go ahead and turn off your volume or mute yourself. Yeah, that's a good point. I didn't even think about that. Oh my goodness. So this square root of 9 here, yeah, it does equal 3, and 120 times 3 is I don't know why this is. Hold on here. Yeah, so this K is equal, I'm going to write it correctly or not at all, you know. But this pen, it's a little difficult to work with. It's just, I don't know. So what you're saying is, I didn't want black. Tell you what, I'm gonna do this whole. No, I'm all right. Let me just. So Yeva, what you're saying is K is equal to 360, right? Give me a thumbs up if that's what you're saying, right? Okay, good, good. So, are there any questions on this kind of problem? You know, again, what you'll see is that they, you know, you have to, based on the sentence here, based on the sentence, you have to come up with the temperature function formula, and then you have to solve for K. And they will give you an initial condition regarding the temperature of the ball, and you substitute in the values in the function that will allow you to solve for K. And then once you solve for K, in this case, K equals 360 degrees. Once you solve for K, now you have a function that that is completely specified, and you can use it and compute, you know, directional derivatives, all that good stuff. Are there any questions on this problem? Who's feeling good with it? Give me a thumbs up if you're feeling all right with it. Okay, Yeva's good, Noreena's good, Samuel's good. Okay, good, good. And I don't know if you had seen this in your homework or not. To be honest, I forget. Aura's comfortable. I just forget because I assigned that homework a while back. But it is, you did. All right, Yeva. So now, if you had trouble with it, you have perspective on that. And, you know, it's a very important kind of problem. It's something that you'll see in physics. You know, it's a kind of a standard kind of problem. And whenever they say something is proportional to something or something is inversely proportional to something, you should know how to, you know, set up the equation. You should know what proportional means and what inversely proportional means. And a lot of you have seen proportional before, but I'm not sure if you've seen inversely proportional, and therefore I'm not sure if you were completely comfortable why the equation's set up this way. Okay, great. All right, well, I will stop the recording then if we're good. All right, excellent, excellent.